As you saw on that last calculation, we have some unit issues related to this equation. It is very standard for delta H's to be reported as kilojoules or kilojoules per mole, and it's very standard for delta S's to be reported as joules per Kelvin. So we've got this big conflict between joules and kilojoules. And quite often delta G's are reported as kilojoules as well. So it really doesn't matter whether you use joules or kilojoules. Remember that they're related by that factor of 1,000. So you'll move the decimal point 3 places to the right to convert kilojoules to the joules, or you'll move it 3 places to the left to convert joules to kilojoules. It really doesn't matter which way you go. Just make sure that your units are compatible, and especially if your handwriting is as sloppy as mine, remember that on entropy, that's Kelvin in the bottom. So that K is a different K from over here, which is the K for kilo. So that the kilo K should be a lowercase and the Kelvin K should be an uppercase. And when I write in printing, you can't tell the difference in my two. So just be careful with units. Okay, so let's put that to the test here. Let's find delta G at 298 Kelvin. At this temperature, delta H is 180.5 kilojoules per mole, and delta S is 24.9 joules per mole Kelvin. So we do have this unit conflict between kilojoules and joules. This time, let's convert the joules to kilojoules, because that's typically how delta G's are reported. So let's just go ahead and start off in the unit that our answer will most likely be reported in. And so if we're going to convert this, we need to move that decimal 3 times to the left. 1, 2, 3. So we'll have to stick a 0 in front there. 0.0249 kilojoules per mole Kelvin. All right, so delta G is equal to delta H minus T delta S, and delta H is a positive 180.5 kilojoules per mole minus T, well, let's see, T is 298 Kelvin, and delta S is 0.0249 kilojoules per mole Kelvin. All right, so in that second term, kelvins cancel out. And let's see, let's go ahead and run this through the calculator. We've got 180.5 minus 298 times 0.0249. That's going to be equal to 173 kilojoules per mole. All right, we hit lots of pieces of these objectives. We got the second law of thermodynamics, that's that the entropy of the universe is constantly increasing. Third law of thermodynamics, setting our 0 point of entropy as a pure crystal 0 Kelvin. We talked about the universe versus the system and the surroundings, and it's really kind of inconvenient to calculate delta S of the universe. We defined Gibbs free energy, delta H minus T delta S. We looked at how the signs of delta H and delta S play for the sign of delta G, and we started looking at calculating delta G using delta H and delta S. We'll continue on that in our follow-up video.